Okay, the easiest way is to choose clockwise as positive. No? The current is going clockwise. So these two will be positive. This one is anti-clockwise, so it's negative. Right? Sum of EMF by Kirchhoff's voltage law. Sum of EMF equals sum of potential difference. So E plus E. Right? This one opposite direction minus E. And there are 3R there. Times your I, the current. So I is E over 3R. Then find the potential difference. Right? V equals to IR. Can
Yeah.
answer is B. No? Sorry. Uh, all that R cancel off. Okay, let's go to the next one. Potential divider. Which change would return the ammeter reading to zero? Yep, yep.
Slide all the way to the
To the left or to the right?
left.
Basically, power supply doesn't matter as long as it's constant. So you cover this up. This has a high resistance. So you want to get balance again, you have to move to the left. Can
Yeah.
what what are isotopes? Yep, these are memory work. Isotope,
Uh, A.
same proton number, different neutron number, different number of nucleons. Okay, see,
Yeah.
neutron is fired at uranium nucleus. Neutron is absorbed by the nucleus, which then splits into barium and krypton. What is the number of free neutrons emitted when uranium nucleus splits up? What's your answer? Either you write down the equation or work with conservation of nucleon number. Right? Nucleon number, you work on the top there. 235 plus 1 minus 141 plus 92. Right? Then you find the number of neutron. No? And can
Yep. Yep.
a pi positive meson has a charge of plus E, where E is a limited charge. It consists of an up quad and one other quad. What would be the other quad in the in the positive meson. Yep. For meson, it must have a, a, a quad and an anti-quad. You want it to be positive. So up quad is 2/3 E. Meson has a quad and an anti-quad. The anti-quad must be 1/3 E to give a charge of E. So A, anti down. Okay, down
Okay.
down is minus E, minus 1/3 E. So anti down is 1/3 E. That's the answer. Okay, let's go to 22. Define pressure, memory work only lah. Force divided by area. Bracket is whether you put in or doesn't put in.
Force
It should be
oh,
normal force divided by area lah.
per unit area.
Per unit force per unit area. But they are not that strict lah. The definition, as long as you got force divided by area, they give you your mark lah. Use the answer in A1 to show that the base unit of pressure is that. Definition of force over area. Force is mass and acceleration. Area is A. The unit force is kilogram meter s minus 2. This is acceleration. 10 more minutes. This is your meter square. Cancel 1 meter. You still got meter minus 1. And kilogram s minus 2. Okay or not?
Yeah.
Okay. Determine the SI unit for base unit K. Yep. What's your answer?
My answer, I got kg meter, no, kg per meter per second.
Okay, subject
Yeah.
K. Subject K. Unit of pi don't have. Pressure we have already derived. R is radius. It's meter to the power 4. Density is kilogram meter minus 3. Time is second. 8 doesn't have a unit. L is in meter. Mass is in kilogram. So cancel the kilogram. Right? There's a minus 1 here. Plus minus 1. So this one and this one will get rid of, cancel off. You still got minus 1. Then s minus 2. S, so you get s minus 1. Can
Yeah.
in an experiment performed to determine the value of K by measuring the value of other quantities in the equation, the value of L and R each have a percentage uncertainty of 2%. State and explain quantitatively. That means you have to use maths already, no choice. Which of the two quantities contribute more to the percentage uncertainty and calculate value of K? So go to the formula. Right? R will be percentage is 2% times 4, right? 8%. L contribute 2%. So R contribute more, the percentage uncertainty in K. Okay with that?
Yes.
State what is meant by center of gravity. Memory work. Point where all the weight
Uh, all
of
the
the
way
object is
of the
taken to
object
act.
considered to act. Uh,
Okay, they are very kind to you. Draw the picture for you. Right? There's a string. There's your mass of 54 Newton. That's your distance from the pivot. And that is the mass, 2.4 Newton, 0.95 meter. And then from the end is 0.35. And then this string made an angle of 30 degrees to the horizontal. Taking moments about the pivot. There's a pivot. Calculate the tension. Some are clockwise,
clockwise
some
equals anti-clockwise.
anti-clockwise. So clockwise, moment about here. Clockwise will be this one, 2.4 times 0.95. And then the other one is these two add together is 1.3. And then take the perpendicular component. So it's d sine 30. Then 54 times 0.45 anti-clockwise. Okay,
Huh? My answer I got 35.7.
I think you may have make some careless mistake somewhere lah. So you may lose a point. No? Can you see your mistake?
Not really.
Huh? Probably
Uh,
you need to check again. No? If yours is the same as mine, and then your answer is different, then you have to calculate again. No? Carelessness somewhere. Check again when you are free.
okay.
Okay, the string is cut so that the beam is no longer in equilibrium. Calculate the magnitude of the resultant moment about the pivot acting on the beam immediately after the string is cut. Right? So moment is caused by this one. No? Right? Resultant moment is 1 point is this one. No? Okay.
22, yeah, I got 22.
The beam rotates where the string is cut and a small block of weight 2.4. Right? This one 2.4. You cut it, it will swing this way. No? Projected through the air. Figure 2.2 shows the last part of the path of the block, right? This is moving. The block is moving from here, 1.8. And then there's your y, this is your x. Calculate the decrease in gravitational potential energy of the block for this movement from x to y. Right? Memorize the potential energy formula, that's all. Write down. Right? Make sure potential energy formula must be written there and put in your value and calculate out. Okay,
Yes.
use your answer in part C1 and conservation of energy to find the kinetic energy of here. So the kinetic energy here and the potential energy here is converted to kinetic here. Right? So we have decrease in potential energy plus kinetic energy at x. Okay,
Yeah.
state the variation, if any, in the direction of acceleration of the block as it moves from x to y. The speed here is obtained from the question paper. That's where we have 3.4.
Positive
Okay.
lah.
Yep.
Positive acceleration.
Right? No variation. Acceleration also is in the same, is vertically downwards.
It means it's positive, right?
You cannot say positive Negative unless you have chosen a direction. No? If you have taken direction downwards, then it's positive. No,
So what is the meaning of variation? Like
no
what
change.
does it
No,
mean?
no change. It's always vertically downwards. Constant, if you like, constant. Acceleration is constant. Okay? Okay now. No variation means
Yeah.
constant now. Right? They are very particular these days asking you to sketch the graph. No? Passes through x at time tx and arrive at y dy. Sketch the graph showing the variation in magnitude of horizontal component of velocity of the block from tx to ty. Right? So horizontal velocity is constant. It's a horizontal straight line at non-zero value of velocity. Okay?
Yep.
Okay, a block pulled by a force x is a straight line along the rough horizontal surface, right? It's rough. Assuming that the total resistive force opposing the motion is 0.8, all the speeds at all speeds of the block, right? That's a variation. So x value is greater this resistive force. So this part you must straight away know that this is acceleration, and this is 0.8 is uniform velocity. Anytime you may cut off. Right? Define force, memory work, determine the momentum of the block from time 0 to 0.3. So force is change in momentum.